Hey, revolutionary greetings to my grade 10 bunch. So, I hope you guys are good. I hope you guys are well. So today we'll actually be going over the homework examples that I basically gave you. I posted some game challenge, if you will, game challenge problems. I posted them on the TikTok page, and I was hoping that people can then be able to do them and then send me their responses. There's one particular student that actually did that a lot. This is grade 10. And I was able to give appropriate feedback for what they had done, right? But yeah, I'm hoping that you guys did attempt those game challenge problems for yourself. We just did grade 9, literally at 7, okay? So now I'm actually busy with grade 10, okay? Simi 21, can't you do grade 12? Not now. Grade 12 I will do, okay? Grade 12 I will do. You just need to, just watch out for when I actually do eventually get into grade 12. For now, I'm still just wiring the grades that are below, but I will definitely start grade 12 at some point, okay? Just need to be patient with me, Simi 21. But hopefully you followed. At the appropriate time, I'll have sessions for grade 12. So now we're doing grade 10, and all we'll be doing today is just going over what we covered yesterday, going over that by way of actually doing the work that I had asked you guys to do. Okay, so remember we looked at multiplying a monomial by a binomial. And remember, a monomial is simply an expression that has one term, and a binomial is an expression that has two terms. So for instance, like x plus 2, that is basically a binomial. Why? Because there are two terms. Terms are separated by a plus or a minus sign. So that's why we say this is a binomial. And then a monomial is one term. So for instance, if we write x is just one term. 2 over 3, all right? When numbers are divided, we also refer to that as being one term. And then let's say, for instance, we had in brackets, if we had x plus 2, this here, even though we know there are two terms inside the bracket, but the minute we put brackets around the x plus 2, this is actually one term, all right? This is two terms, typically speaking. But the minute we put brackets around it, then we refer to this as being one term, okay? So hence, you need to understand the whole monomial and binomial thing. That's something that you covered in grade 9. Head office 2, grade 12, like I said, I have not, as of yet, started any session lessons with grade 12. But when I do, trust me, you will know. And when I actually do that, I'll actually post a relevant schedule on the page so that the grade 12s are very much aware. I do just want to let those grade 12s know that I'll be going according to the order of the ATP, the annual teaching plan for term 1 when I do start. And most probably I'll only start with grade 12, if possible, on the 27th of this month. Okay, for now, I've been doing the grade 8s, 9, 10s, and the 11s. I think more specifically the grade 9s and the 10s and the 11s have been getting the best of me, more especially the grade 9s and the grade 10s, okay? So if you guys are coming in and you're joining for the first time, maybe you are in grade 10, or maybe it's a parent that's like mistakenly actually come across this live session, please do go and subscribe to my YouTube channel. It's called Maths is a Game as well. If you want to locate it easily, you can just go to my homepage of this TikTok page, go and click on the YouTube icon that's there. It will send you directly to the link for my YouTube channel. You subscribe, then you can actually go and watch the previous live sessions that I've done so far for the term 1 work for grade 8, for grade 9, for grade 10, and for grade 11. And then you can catch up so that when I restart the sessions again on the 27th and continue from where we left off, your kids can be at the same place that the rest of the kids are in. All right, so I will leave it at that. But today I'm doing corrections for the work that we had started doing yesterday, which is basically the multiplications of monomial and binomial. Okay, that's grade 9. Guys, I have a scheduled grade 9 session, so which I'm busy with now. Okay, all other grades, okay, at another time. So first question that was in your game challenge was 3x into x plus 3. We remember yesterday we said that whenever we do these problems, we basically use what we refer to as the distributive law, and we apply, when we do use the distributive law, we apply S and L. In other words, we multiply the signs first, then we multiply the numbers next, we multiply the letters lastly. So let's do this. 3x is outside a bracket, which is x plus 3. So 3x must be distributed to x by multiplication using applying sign, multiplying the signs, multiplying the numbers, multiplying the letters. Guys, you may have seen S and L when you are watching a particular movie, and it does not really go down so well when you are watching a movie and it has S and L. It means something when you are watching a movie. But in maths, when you are dealing with monomial multiplying a binomial, the S stands for you multiply the signs first, you multiply the numbers next, you multiply the letters next. So every time, maybe from today onwards, whenever you come across a movie and it has S and L, maybe it's a very good time to actually switch off the television screen and actually go and do some maths. Sign, numbers, letters. Let's go. Okay, so 3x into x plus 3. So let's multiply the signs first. 3 is positive. The x, there's a 1 here and it's also positive. So positive times a positive gives us a positive sign. We are done with the sign. Let's move on to the number. 3 times 1 is equal to 3. So we have a positive 3. Okay. Then x times x. Remember, when we multiply variables at the same base, what do? We keep the base and then we add the exponents. Remember, there's a 1 here that's an exponent and there's a 1 there that's an exponent. It's always there, but we don't see it. It's like the Holy Spirit or God or something that you don't see that's present, but you can't see it, right? So there's a 1 there and there's a 1 there. So you keep the base and then what do you do to the exponents? You add them. So 1 plus 1 will give you 2. So we have 3x squared. So that's the distribution of 3x to x using the sign. You multiply the sign, you multiply the numbers, you multiply the letters. Then you take 3x, you distribute 3x to positive 3 again. You distribute, you apply sign, number, letters. So what's positive times a positive? It's positive. That's the sign. Then you move on to the number. What's 3 times 3? It's 9. Then x is alone. It has no complementing x base, so x is written next to the 9. It's combined. So the final answer is 3x squared plus 9x. You ask yourself, are these like terms? In other words, can you add these two terms together? Are they like terms? Remember, what are like terms? In grade 9, you learned that like terms are terms that have the same variable but also the same exponent. So 3x squared, is it a like term to 9x? No, it's not. And what do we know about unlike terms? So it's not like terms. So therefore, can we add those terms together? No, we can't. So we leave those terms as they are. So the final answer is 3x squared plus 9x. Okay. The explanation I gave was long because I just wanted to catch up those people that feel like they were not here for the previous lesson. Now I'm going to move at a very fast pace. when I do the next ones. So hopefully we are all understanding the approach when we do these problems. Okay, Chasey, all right, I have moved on. So when are you going to have to go and subscribe to the YouTube channel and actually rewatch that part. So I'm moving on to the next question. The next one was x minus 5 into x minus 2. Okay, all right, what do we have here? We have inside the bracket we have a binomial, and inside this bracket we have a binomial, two terms. So it's a binomial multiplied by another binomial. All right, so what do we do when we are multiplying a binomial by a binomial? We still use the distributive law, and when we use the distributive law, we ensure that we apply S and L. Multiply the signs, multiply the numbers, multiply the letter. So x needs to first be distributed to x, and then after that x needs to be distributed to negative 2. So let's start there. Whoa, x times x, sign, number, letter. Let's start with the sign. Positive times a positive is equal to a positive, so the sign is positive. Then number, we know that there's a 1 here and there's a 1 there. They are always there. Okay, it's not 0 that's here, it's 1 that's before this x, even if we don't write it down. So what's 1 times 1? The number, it's 1. Okay, whether you write that 1 or you don't, it still means there's a 1. Okay, and then what's x times x? We move on to the letter. When we're multiplying same bases, we keep the base. Remember, there's a 1 at the top here and there's a 1 at the top there. What do we do to the numbers that are exponents? We keep the base. When we are multiplying, what we do to the exponents? We add them. What's 1 plus 1? It's 2. So it's like saying 1x squared or x squared. Then we do the same thing. 1x times negative 2. Sign, positive times a negative, negative. 1 times 2, 2. The x next door, because it's the only x, it's combined to the negative 2. After distributing the x to both terms on the other bracket, we take the negative 5. We start distributing it to the x first. We take the negative 5 again. We distribute it to the negative 2. So let's do this. Okay, what's negative 5 times x? So negative times a positive is negative. Sign. Then the number. 5 times 1? 5. Then there's nothing here, so times the x means we combine the x next to the negative 5. No, this is not factorization, this is multiplying out, this is products. Okay, so please let's go. Then last, negative 5 times negative 2, sign, number, letter. Let's start with the sign. Negative times a negative is positive. The number, 5 times 2 is 10. All right, and then we can see we have 4 terms from our multiplication of the binomial by a binomial. Then we check, do we have like terms in the expression? X squared minus 2x minus 5x plus 10. Our like terms are negative 2x and minus 5x. We can clearly see that they are like terms. Why? Because the variables are the same. The exponents are the same. But x squared is not a like term to these two terms. So final answer, we write the x squared, obviously. What's negative 2x minus 5x? Remember, when we are adding like terms, what do? We keep the variable and then we add and subtract the coefficients. If you took your calculator and you said minus 2 minus 5, minus 2 minus 5, you will get an answer in your calculator that is negative 7. So your final answer is negative 7x plus 10. That is the finality of your answer. You leave it like that. Why? Because x squared, 7x, and 10 are not like terms. Why? Because their variables are not the same. This x has an exponent 2, this x has an exponent 1, and this is a constant term. So you cannot add these three. You leave it as it is. Final answer. Okay? Maya he, Maya ho, Maya ho, Maya ho ho. Right, next one. 3. All right, here we are. Next one. Yes, this is a great then, Tricia. Okay, what about this one? Binomial by a binomial. So by now we know what we ought to do. Sign, number, letter. 3x times 2x in your head. Sign, positive times a positive, positive. 3 times 2, 6. X times x, keep the base, you add the exponents. 1 plus 1, 6x squared. Done. 3x times positive 3. Sign, number, letter. Positive times a positive, positive. 3 times 3, 9. X next door to the 9. Then we take the negative 1, we distribute it to the 2x, take the negative 1, distribute it to the positive 3. Negative times a positive, negative. 1 times 2, 2. X next door. And then last but not least, minus 1 times positive 3. Negative times a positive, give negative. 1 times 3, give 3. And then that basically gives us our 4 terms in our expression. Okay. Sunny boy, you are funny. Now, do we have any like terms? Seems like we do. Once again, the middle terms are actually like terms, and you can see that because this x, negative 9x and negative 2x are like terms. So final answer, 6x squared. This is core. 9x minus 2x is 7x. And then last term, give minus 3. Can we add these terms? No, we can't, because they are unlike terms. Okay. No, you're not dealing with algebra only, all right? We're not dealing with algebra only, but it covers a large aspect of it in term 1, all right? Okay. So there's other things that you'll be doing. Yeah, the grade 10 trigonometry is coming up, but obviously, like I said, I am following the program for the term from the beginning until the end. So you cannot take for granted what is done at the beginning. Okay? When the time comes, when trigonometry is covered, I will cover it. But for now, I'm covering this. Okay? Yes. Trigonometry is covered later on in the term. And when it's covered, you guys will be happy that it is covered then. But we need to master this first, okay? Your trigonometry will suffer if your algebra is weak. If your algebra is weak, your trigonometry is in trouble, okay? So let's make sure that the basic algebra is sorted and we are good, okay? Yeah. Then number 4. The next question that I gave you guys was this one. Was this one, okay? 2x to the power 4 minus 3y squared in the first bracket into 3x to the power 4 plus 2y squared in the other bracket. So let's look at multiplication. So once again, distributive law using SNL. Multiply the sign, the number, the letter. Yes, FOIL. So we multiply the first terms, multiply the outer terms. So it's like 2x is first distributed here, and then 2x to the power 4 is distributed there. That's the first thing. So let's go. Sign, number, letter. Sign, positive times a positive, positive. 2 times 3, the number, 6. X to the power 4 times x to the power 4. We keep the base. What do we do to the exponents? We add them. What's 4 plus 4? It's 8. 2x to the power 4, we multiply the last term. Positive times a positive, positive. Number, 2 times 2, 4. Letter, x to the power 4 times y squared, x to the power 4 next to y squared. Okay, right. Then, next one. We take the negative 3y, we distribute to 3x to the power 4. We take the negative 3y, we distribute to 2y squared. Ntabi, I don't understand what you mean, but where is the middle sign? Okay, I don't understand that. Maybe you need to tell me what do you mean, which middle sign? Okay, so negative 3y squared times 3x to the power 4. Negative times a positive is negative. 3 times 3 is 9. Y to the power 2 times x to the power 4. I usually insist on making sure that I write these in alphabetical order. So x first, x to the power 4, followed by y squared. Why? Because that just helps me with understanding or checking whether these are like terms or not. And if the order of my letters are the same, then it makes life very easy for me. Okay, Miss Gao. Yes, we didn't because I had a bit of a problem. So those who were actually in the WhatsApp group, I informed them so that they know that I couldn't. It was a bit crazy here at home, so I couldn't have a session. That's why I'm having a grade 11 session at 9 with the grade 11s. Okay, so that was not me fooling you or playing with you, but it's just that, like I said, circumstances just did not allow me to. Okay, negative times a positive is negative. Then 3 times 2 is 6. Then y squared times y squared is y to the power. We add the exponents because the bases are the same. Y to the power 4. Okay. Then we can see that they are actually like terms. YouTube channel is called Maths is a Game. Okay, Maths is a Game. Just like the TikTok page. You can go onto my bio. Go to the YouTube icon, you can click on it, it will send you directly or straight. I think the YouTube icon actually is attached to my YouTube page. You can click on that, it will send you directly to the YouTube page. Okay. Okay, so let's go again, guys. Then we can add the like terms. 4x to the power 4y squared minus 9x to the power 4y squared. These are like terms. Why? Because look at the variable and the exponent, variable, exponent. Look at this variable, exponent, variable, exponent. It's like they are wearing the same jersey, these guys. Everything is the same, the variable together with the exponent. So we can add the like terms. So we're going to keep the variable, and then what we are going to do to the coefficients, the numbers before, we are going to add or subtract them. What's 4 minus 9? That's equal to negative 5. Okay. Okay. And then last but not least, minus 6y to the power 4. Okay. All right. Okay. Hope we could. Hope that one was not too shabby for us. Okay. Okay, so let's go on. Number 5. Minus 3a into okay, so now we have a monomial by a trinomial. One term outside the bracket with 3 terms in the bracket. Okay, so we once again apply the distributive law using SNL. Distribute negative 3a to 3a cubed. Distribute negative 3a to 6a. Distribute negative 3a to 9. All 3 terms using sign, number, letter. Let's go. Sign. Negative times a positive, key negative. Number. 3 times 3, key 9. Letter. A times a to the power 3. We keep the base. We add the exponent. Remember here, a has the exponent 1. It's there, guys. It's always ever abiding there. Unseen, but ever present. 1 plus 1 gives us, we keep the base, we add the exponents. 1 plus 3 is 4. Next one, negative 3a times negative 6a squared. Thank you, JC. Negative times a negative, key positive. Number, 3 times 6, key 18. Letter, 8 to the power 1 times a to the power 2. Was it? All right. Thank you so much for that correction, Snowboatly. Okay. So it was a at the end. Sorry, guys. My bad. A student of mine who got the homework nicely actually corrected me that there was an a at the end. Okay, not a 9. Okay, I think I wrote it kind of weird. So it's a there at the end. Okay. Thank you so much, Snow. Really appreciate that. Okay, all right, so where was I? It was me multiplying the monomial by this term. So I said a negative times a negative, positive. 3 times 6, 18. A to the power 1 times A to the power 2. Thank you so much. I saw Cool Kid did say Shem, A to the power 3. Good job, Cool Kid. A to the power 3. Then last monomial by the last term. Negative times a positive is negative. Number. So there's a 1 before this A. It's always there. Don't see it. 3 times 1, 3. A to the power 1 times A to the power, there's a 1 there, is A squared. Thank you so much, Lohiti. Really appreciate that. Okay. Remember, 1 plus 1 gives you 2. You keep the base variable A and you add the exponents. Okay. Let's not forget that. So important, guys. Law number 1 of exponents as learned in grade 9. Then, do we have any like terms? A to the power 4, A to the power 3, A squared. Are these like terms? I corner. So therefore we leave. Please guys, don't find yourself wanting to add 9 and 18 or add these things to. You can't add unlike terms. Unlike terms cannot be added. That's what you learned in grade 9, right? Okay. Okay, let's go. All right, let's x plus 5 into x minus 2. Let's go. Okay, this one is easy, must say. Once again, we are applying distributive law using S and L. I think some people have this thing about factorization a bit misunderstood. Please, guys, we are currently doing products, multiplying, okay? The reverse of products is factorization. We are not there yet. We are not there yet. Okay, we are not there yet. But when we get there, you will know. Okay, so this is a binomial by a binomial. Okay, binomial by a binomial, and brackets mean multiply. So we use distributive law, FOIL. Thank you, Tilana. Thank you so much. Thank you so much. So x times x, we multiply the first terms, x times x, sign number letter. Remember, sign, positive times a positive, give positive. Number, 1 times 1. Remember, guys, there's a 1 and a 1 here. Okay, how is ahead of the game. X times x, x squared. Then we take the x, we distribute it to the negative 2. Positive times a negative, give negative. 1 times 2, give 2. X next door. 5 times x, positive times a positive, give positive. 5 times 1, give 5. X next door. And then last but not least, 5 times negative 2. Positive times a negative is a negative. 5 times 2 is 10. Do we have like terms? Seems like we do. All right. So what do we do to the like terms? We keep the variable for those like terms. So our final answer will be x squared. We keep the variable, we add the coefficients. Coefficients are the numbers before the variables. Negative 2 plus 5 gives us positive 3. And then obviously our constant term, negative 10. Are these like terms? No, they are not. So we leave the answer there. It's x squared plus 3x minus 10. Okay, I am not going to do this one. Hopefully those who are joining in for the first time can do it. Binomial by a binomial. Sign number letter. 7m times 3m. I'm going to see in the comment section. 7m times 3m. Some are commenting after you said the answer. That's why I'm basically going to keep quiet now so that people can get the chance to comment without me saying anything. 7m times 3m. Okay, Ikuku says 21m. Paula says 21m. Owami says 21m. Skri says 21m. Nomi says 21m, and I'm guessing that 2 means squared. Lizelle says 21m. Norma says 21m. Guys. Right, let's understand this. Remember, I said given Jan says 21m squared. Please, guys, take note. Given Jan is grade 11. I have grade 11s coming in here. Anyways, 7 times 3. Sign number letter. Remember, positive times a positive, give positive. 7 times 3, give 21. Guys, m times m. Remember that when variables are the same, law of exponent number 1 says we keep the base. What is the exponent that's here? There's a 1 there, we don't see it. So what do we do to the exponents? We add them. So that will give us 21m squared. Okay, so let's avoid not taking into consideration the impact that variables that are the same will have when they are multiplied together. So it's 21m squared. Okay, now it makes me a bit sad that we have people that are saying 21m alone without the m squared. Seho, I'm glad you're on holiday. Enjoy it, please. Enjoy it. Okay, so hopefully we are good. Let's move on to the next one. 7m times positive 4n. Sign number letter. What will be the term? Hey. 7m times positive 4n. Pinzo 28mn. Snowcoat 28mn. Scree 28mn. I think no, we might have just omitted the 8, I'm guessing. Lizelle 28mn. And so it goes. Yes. Right. Okay. Yes, guys. It's plus. And please, you need to show the sign here. 28mn. You guys are spot on. Then we take 2n, we multiply negative 2n times 3m. Maholobela, just hang on, eh? I understand. I just want to do term by term so that we can kind of see where people are actually going off, all right? It's no otherwise. Thank you though. I really appreciate it. I can see that response there. Nomi negative 6mn. Paula, negative 6mn, or Paula, sorry. Okay, nice. Okay, negative times a positive, give negative, 2 times 3, give 6, n times m. In alphabetical order, we just write mn. Okay, we can clearly see these are going to be two like terms, which is good. Then last term, 2n, negative 2n times 4n. Negative 2n times the positive 4n. What do we get? Yeah, Maholobelo, you're fire. I can see that, which is epic. And okay, Nomi says negative. It says 8n squared. Snowgotla says 8n squared. Norma says negative 8n squared. Good job, Norma. Norma, you had answered at the beginning 21m, m only, not without the squared. So I'm actually happy that you are catching on. That it's now sign negative times a positive, negative 2 times 4, d8, n times n. We keep the base. The exponents are 1 and 1. Don't forget that. N to the power 2. Okay, so I'm hoping all unbelievers now can see that God does exist. Why? Because the one that you see, that you basically don't see there, is like sort of like the unseeable one. It's there, but we just don't ever write it, right? Goodbye, JC. It was good having you. So final answer, 21m squared. So if you didn't believe before, I hope you believe now. Like terms, you add them. 28mn minus 6mn gives us what? It gives us a nice answer of, because they are like terms, it's plus 22mn, because we keep the variables mn, but what do? We add or subtract the coefficients. 28 minus 6 is positive 22. Then the last term is negative 8n squared. Can we add anything else now? No, we can't, because there are no more like terms. Okay. Right. I'm gonna do two last ones. Why? Because I have a grade 11 session that I have to honor, and the grade 11s have not been having a good time with me because I haven't honored sessions with them. So I'm going to do 2 last ones, all right? And these 2 last ones, I think they are important for me to do because I noticed something with someone that had decided to actually send me their work privately to me, and I really appreciated that person sending me their work. Yeah. Tricia, after 11, I'll post a follow-up, if you will, homework for you if you want, so that you guys can actually hammer this thing in, right? I'll do that for you guys, okay? And even those who probably didn't get a chance to do the rest, there are more exercises. The video that I posted, for instance, yesterday, is there for you guys to basically go ahead and do. Okay, that's fine. If you're doing baseline assessments when school reopens, that's good. That's good. You've got a good teacher. If that teacher is gonna make you guys do baseline, all right. So when you'll be on top of your game. All right, let's do this one, guys. First term. Tell me, comment section. Let's go. 4x to the power 4 times 2x to the power 4. Multiply sign, multiply number, multiply letter, and apply the laws. So first term that we get will be, please let's do it step by step, people. Don't write the whole answer for everything, right? Just the first 4x to the power 4 times 2x to the power 4 will give us I thought the song would encourage you guys, 4x to the power 4 times 2x to the power 4. Anyone? Yes, which is fine. So let's write the answer. You can write the answer in the comment section for what you get when you get 4x to the power 4 times 2x to the power 4. That's fine. You can do that. Musa says 8x to the power 4. What does everybody else say? If we multiply 4x to the power 4 times 2x to the power 4, the final answer we get is Hope says 8x to the power 4. Nomi said 8x to the power 8. Tricia says 8x to the power 4. Celine says 8x to the power 16, and she's laughing. Kitty Brown says 8x to the power 16. Scree says 8x to the power 8. Sam says 8x to the power 8. Given, no, you cannot try. Don't try. 8x to the power 16. Okay, guys, remember when we are multiplying, sign, number, letter. Positive times a positive is positive, so it's a positive answer. Number 4 times 2 is 8. X to the power 4 times x to the power 4. Now I'm going to actually do this. 4 plus 4. I'm going to do this because it seems like some people need me to actually write this down. I don't know, Mrs. Gao. I have no idea why. I'm not going to lie to you. I don't understand why you can't answer. People are allowed to answer. I've not limited or blocked I've not done anything myself, so you should be able to answer. You've just done so now. You've commented. Okay, so 8x to the power 4 plus 4. Okay, which would basically give us 8x to the power 8. Hopefully we understand that, please, people. We multiply the sign, positive times a positive is positive. We multiply the numbers, 4 times 2 is 8. When we multiply the letters, when bases are the same for exponents, we keep the base, we add the exponents. We don't multiply the exponents, we add them. Okay, please, people, that's why we get 8x to the power 8. Are you with me? Hopefully we are on the same page here. 4x to the power 4 times negative 4y to the power 3. What's the answer? I want the answer for the next term. 4x to the power 4 times negative 4y to the power 3. What do we get? Pian, that's why I quit maths. Okay, we have 16x to the power 4y to the power 3 as a response. Snowcoater says negative 16x to the power 4y to the power 3. Motebang says 16x to the power 4y to the power 3. So let's check this out. Sign first. Positive times a negative. What's a positive times a negative? It's negative. Well, that's where we start. We start with the sign. Then we move on to the number. 4 times 4 is 16. Okay, sign done. Number next. 4 times 4 is 16. Then we move on to the letter. X to the power 4 times y to the power 3 is simply x to the power 4 combined to y to the power 3 next to each other. So that is our term there. Okay, so good job to those who got that right. Let's move on to the next term. 3y to the power 5 times 2x to the power 4. Sign, number, letter. 3y to the power 5 times x to the power 4. Okay. See, the y is to the power 5, the x is to the power 4. So sign, number, letter, what do we get? Sent Galaxy, you're killing me. King A12. How sweet it would be if that would be an actual physical, the actual gift. You're sending me a picture, Galaxy. Guys, it's Christmas Eve. What are you talking about? What is this? You funny King A12. So, what is it, guys? Positive 3y to the power 5 times 2x to the power 4. What do we get? Sign, positive times a positive is positive, right? 3 times 2 is 6. Then x to the power 4 and y to the power 5 are different variables. So we place in alphabetical order x to the power 4 alone combined with y to the power 5 alone. Okay, I insist on alphabetical order because it just helps me with my sanity. I have x to the power 4 here, I have x to the power 4 here. I have y to the power 3 here, I have y to the power 5 here. It helps with the order. Then the last terms that we multiply. Positive times a negative. Start with the sign. What's a positive times a negative, guys? Positive times a negative is negative. 3 times 4 is the number after that. 3 times 4 gives us. How can you be writing paper 2 but it's Christmas? Are you kidding me? It's 12. Very good. And then y to the power 5 times y to the power 3, guys. What's y to the power 5 times y to the power 3? Y to the power 5 times y to the power 3. What does the law say? We have same bases. So what do we do? Y to the power 5 times y to the power 3. We keep the base. We add the exponent. So the answer will be y. Very good. Y to the power 8. So I'm just going to do that thing again and say 5 plus 3. Alright? As the exponent. So that you guys can see that we must add the exponents, not multiply them or any funny answer. So finally we have going to have 8x to the power 8, 16x to the power 4y to the power 3. Sorry, my bad. Let me just rewrite this. 8x to the power 8 minus 16x to the power 4y to the power 3 plus 6x to the power 4y to the power 5 minus 12y to the power 8. Now, look at these middle terms. Are they like? Do we have any like terms in our expression? Okay. Now, we must not get into the routine of thinking these are always going to be like terms. Take note, guys. X to the power 4. Okay. X to the power 4. Okay. Same. Y to the power 3. Y to the power 5. These are not the same. So for once, for this problem, we are going to have to leave the answer in this state. Do you see? Right? Because these are unlike terms. Right? Okay, I hope it's coming, guys. I hope it's coming. I'm going to do one last one. The grade 11s just need to kind of wait for me. Okay? They have to wait for me. Safer, this is not factorization. We are multiplying out here. Okay? So if we are multiplying out, we expand and then we simplify, and our simplification stops here. We are done. We are not doing factorization, we are doing products, expanding and simplifying. So we end here. Please take note of the question. Okay, we are doing products. Okay, no problem, Safer. It's no problem. Okay, no problem. All right. Yeah, we can't go on. Yes, we can't go on because here we are dealing with a expand and simplify. Okay. Okay, we are not factorizing. Guys, we are coming to that. Like, we are still doing multiplying out. Can't you multiply 16? Can't you divide 16 and 6? Why? Explain to me why. Why are you going to divide 16 and 6? The relationship between this negative 16x to the power 4y to the power 3 and the addition of 6x to the power 4y to the power 5. Why are you going to divide? Why? Okay, right? Yeah, and please, let's not have misconceptions, okay? The last question I want to do for us is when we have a binomial by a trinomial, and I'm just going to choose one of the problems that I basically gave you, and we'll do that for just the concluding question. Grade 11s, just hold your horses. I'm actually going to be with you shortly. I'm going to end this live session at 10 past exactly and then restart it, and probably grade 11s will start at 20 past 9. Okay, grade 10s, so this one is a binomial by a trinomial, right? Okay, what did we do first? A monomial by a binomial, one term multiplied by two terms. Then we've just looked at binomial by a binomial, two terms multiplied to each other. Then we did one where there was a monomial, meaning one term multiplied by three terms. Okay, and for all of these, what we are doing, we are just applying the distributive law. We are distributing. This is grade 10. Those who are coming in, grade 10. Yes, this is the early Christmas gift, Malcolm Chipanga and Mitch. Those who are coming in, you are asking on Christmas Eve, this is the early Christmas present for the grade 10s that are going to grade 10 next year. Grade 9s who are going to grade 10. Okay, subscribe to this channel. You will always get the best of the best for your maths. So you can get, we can level up. You know, the early Christmas gift is designed to help us level up so that we can level up to level 7. You know what I mean? Next year. But it's early. All right, so distributive law, look at this. 3x, we're going to distribute to 9x squared, S and L. 3x, we're going to distribute to 6xy, S and L. 3x, we are going to distribute to 4y squared, S and L. That's fine, Motabeng. Kaloko, the grade 9 work was a introduction to grade 10. So if you've done this in grade 9, very good. It means you are going to smoke grade 10 most. You are going to kill it if you are going to be doing pure maths next year. All right? It's because this is what you do in term 1. All right? In the second week, you do this. Right, so let's go. 3x times 9x squared. Let's first distribute 3x all the way to all three terms. Let's start there. Let's go. 3x times 9x squared. Remember, distributive law using S and L. We multiply the signs, we multiply the numbers, we multiply the letter. So what is our first term? Eno has just helped us out there very nicely. Positive times a positive is positive. 3 times 9 is 27. X times x squared, what do? We keep the base for same variables, we add the exponent. It's 1 plus 2. So now I'm going to write out this thing because some people are butchering the answer for the variables. So I'm writing out this 1 plus 2 so that in the next step I'm going to write 3. Typically, I don't do this when I'm answering the question. I just go ahead and write 27x to the power 3. Why am I doing this? For those that basically don't take it into consideration when they do it, so that you know you are adding exponents, okay? Yes, you are going to smoke it. I love it. Then we are done with the first term. 3x, now we are going to multiply with positive 6xy. So what do? Sign, positive times a positive, keep positive. Number, 3 times 6, I love it, 30 3 times 6, 18. Then x times x. Bases are the same. We keep the base, we add the exponent. There's a 1 and a 1. Just like Holy Spirit, God can't say but present. 1 plus 1. I wouldn't typically do this. I would just write 18x to the power 2. But I'm doing it for those that don't seem to get it. Then the y variable, we write it next door to the x. Are we together? Are we together? I love it. 3x we distribute to plus 4y squared. Positive times a positive, key positive. 3 times 4 number, key 12. X times y squared, different variables next door to each other. 12xy squared. We good? Amen. Hallelujah. Then 2y now needs to be distributed to the 3 terms. Negative 2y. Remember, the sign for 2y is negative. So we start with the signs. Again, negative times a positive, key, negative. 9, 2 times 9, key, 18. Y times x squared. Order. X squared y. Alphabetical order is me. All right. Now, people, you see, my space here is not enough. So what I'm going to be doing is I'll write in the next Landuka. But please, people, we need to keep the terms in one row. All right. I'm just gonna do that because I just did not really. I shouldn't have just written this without considering the space that I have. Okay. Next one. Negative 2 times positive 6y. Let's go. Negative times a positive is negative. 2 times 6 is 12. Y times xy. So the x is alone. We write it as the alone man that it is. And then y times y. Give y to the power 1 plus 1. Okay. And then the very last term, negative 2y times 4y squared. Negative times a positive is negative. Okay, so please, people, this would be on one line. It's just that I'm having to use this one because I did not really see. Negative times a positive, give negative. 2 times 4 is 8. Y times y squared, give y to the power 1 plus 2. Okay. So now the finality of what I see is 27x to the power 3, because 1 plus 2 is 3. The next one, plus 18x to the power 2y, because 1 plus 1 is 2 in the exponent, plus 12xy squared minus 18x squared y minus 12x. Remember, I had a 1 plus 1 there, which gives me in the exponent 2y minus 8y to the power 3. These are how many terms? 1, 2, 3, 4, 5, 6 terms, which makes sense because if 3, I'm going to distribute 3 times, that's 3 terms. And then if I take negative 2 and distribute it 3 times, that's an additional 3 terms. So in total, I should have 6 terms, which makes perfect sense. Now, identify the like terms, if there are any. Now, let me just do the following. You don't have to do this, but I do this just for identification and for the purpose of teaching. 18x squared y. Who is the like term to 18x squared y? It's negative 18x squared y. They are like terms. Plus 12xy squared. Something is off here. Oh, look at that. Do you see what I did here? This second last term. Remember, this negative 2y was multiplied to plus 6xy. And remember what happened. I said negative times a positive is negative 12. Then the y times the xy. I should have kept the x, which I did here, and I said 1 plus 1 for the y. So I should have gotten 12xy to the power 2. So there's an error here that I made. There's supposed to be 12x with 1 nothing here, and then the y should be 2 to the power 2. Okay, please people, this was just a typical error of not actually checking. You see now, that's why it's important to actually have enough space to write, because you will make these silly errors, and then they will affect you. Okay, so let's go back. Plus 12xy squared is a like term to negative 12xy squared. So they are friends. They are friends. They are wearing the same jersey. So like terms can be added or subtracted. 27x cubed has no friend. 18x squared y and minus 18x squared y. Now look at this, guys. The variables are the same, but the coefficients, plus 18 minus 18, if you take your calculator and say 18 minus 18, what do you get? You get 0, guys. So in other words, this is actually 0x squared y, if you would like to say. Negative 18x squared y minus 18x squared y gives you 0x squared y when you add those like terms. Let's move on to these, the ones that we've written in circles. They are also like terms. 12xy squared minus 12xy squared is also 0xy squared. Make sense? And then last but not least, we have negative 8y cubed. But people, if you take 0 and you multiply with these variables, what do you get? You get 0. And if you take 0, you multiply with this xy squared, you also get 0. So basically this is all 0, and therefore our final answer has to be 12x cubed minus 8y cubed. That would have to be our final answer, because 0 multiplied, remember the relationship between 0, x squared and y is one of multiplication. It's like saying 0 times x squared times y. Anything multiplied by 0 gives us 0. This here is also like saying 0 times x times y squared. Anything multiplied by 0 is 0. So therefore, our middle here is 0. And finally, we can actually say our answer is 27x cubed minus 8y cubed. This is something that we need to take note of. All right. So guys, I am going to have to love and leave you exactly here. My grade 10 learners, thank you so much. It was good that you joined in the session. Please do make it a point that you go to the main page, the TikTok page. There's a video that I posted of exercises. I don't call these homework, I call them game challenges. Maths is a game, guys. The more you play it, the easier it gets. The more you enjoy it, then the more success you have. So what you guys need to do, please, is please just go onto the main page, go and do the rest of the exercises. Okay, I didn't do all of them. There's like 1, 2, 3, 4, 5, 6 problems that I didn't do from that game challenge. So go on there, go and do the rest, applying what you've learned from what I did today. All right, and then tomorrow I'm not going to have a maths live session. All right, you guys can enjoy your Christmas with your family, enjoy it. On the 26th, I'm not going to have a maths live session. You can enjoy Christmas, enjoy your time with your family and all of that. On the 27th, I'm back with vengeance. It's not even funny. On the 27th of December, I'm back with vengeance. And we are going to pick it up from products and move on to factorization. There's also a WhatsApp group, okay, that has been started by the grade 10 group that I usually have a session with here on the TikTok live math sessions. I believe, just want to see if this person is actually here on the live, but I hope they can indicate in the comment section that if there are people here that are in grade 10 that are in that maths group, please just do indicate in the comment section that I'm in the group. You guys can send those people a message on a private message. Please don't write your guys' numbers on a video on the comment section. It's not good, guys, to write your numbers there. Okay, Oh wow, on your birthday, that's sweet. That's fine. Then you should definitely be on that session. Then it will be beneficial. Yes. So all these people that are saying I'm in the group, please just follow them, send them a private message so that they can add you in the WhatsApp group. Because any messages that are related to when I'm doing the live sessions, maybe any additional material that I'd like to share with you guys, or anything else that's helpful for you guys with your maths, I will send in that group. It's grade 10, guys, okay? For now, it's grade 10. I've had to actually just drag the grade 10 session a bit longer because the grade 9 session was a bit longer. So I'll start with the grade 11s very soon. So please follow those people, send them a private message, let them add your number onto the WhatsApp group, okay? Grade 10 WhatsApp group. And then, like I said, any further communication that has to deal with the sessions that are coming up, I will send there. Any additional material, any tests. By the way, we will be eventually, at some point, after we covered a certain amount of work, write a test. A Maths Live test, if you will, and all of those things. So please do that. And yeah, enjoy your guys' time with your family. Enjoy your Christmas. Enjoy everything. And then I'll see you guys when? On the 27th of what? Of December. I'll be back with vengeance so that we can smoke the maths and just have a good time with it. Maths is a game, guys. The more you play it, the more you get familiar with it, the easier it becomes, the more joy you will have. And when maths is easy, guys, to be honest, it gives you confidence to basically attend to all your other subjects, okay? So do that, and yeah, enjoy. Thank you so much. It was really good. So yeah, please do also subscribe to the YouTube channel if you are new. The YouTube channel is on the Oh, okay. Yeah, so guys, thank you so much. It was good, it was real, it was awesome. Like I said, if you go to my bio, there is a YouTube icon. You can click on the YouTube icon, it will send you to my YouTube page. There I've uploaded the videos for the live sessions that I've done in the past weeks for grade 9, for grade 10, so that you can get caught up on what we have done. The videos are a bit long, and I think part of it is a lot of rambling because, for instance, this information now that I'm sharing with you will be on the next YouTube video, because I'm going to download this, upload it on the YouTube channel so that people can watch it. So make sure that you basically move to the place where I start teaching, so that you don't listen to all the other things that really are just not important, okay? But thank you so much, guys. I think the grade 11s are waiting, so I'm going to end this live session. Okay, I'm going to end this live session. Like I said, we're going to start back up for grade 10 on the 27th of December. You have a break tomorrow, enjoy Christmas with your family, and then on the 26th, enjoy Boxing Day, whatever that means. And then I'll see you guys on the 27th. We'll pick it up from products, go on to factorization, go on to equations, go on to exponents, go on to trigonometry, and all of that stuff. So yeah, there's a lot packed for us and prepared. We'll be writing tests and all of that stuff. So please do join that WhatsApp group. All those people that have said, that have basically indicated they are there in that group, follow them so that you can send your number to them and then they can add you in the group. Thank you so much. Thank you again. I'll see you again. Grade 12s. I haven't started no sessions with you guys. I think only after the 27th. In fact, on the 27th, I'll post the schedule on the TikTok page as to when we are starting with grade 12. Okay? Yeah, so that we can start with you guys as well. Thank you so much. Let me see you guys when I see you. Cheers, cheers, cheers. Thank you. Grade 11s, I'll be with you now. I just need to end this live session and start again so that this video does not interfere with that one. Thank you.